Welcome back to a new session on MOOC on Information Security, and in this session we will discuss aspects of security. Here we will try to define the various aspects of security. From the previous session, we have already seen the terms confidentiality, integrity and availability. Here we will explain in detail the model and methods of confidentiality, integrity and availability. Information security is a necessary precondition for the operational use of information systems and the informational self-determination. Unfortunately, the actual relevance of information security is often only recognized when absent. Although the industry is continuously working hard to make the information and internet more secure for users, the more and more complex business processes and technologies make it difficult to gain the user's confidence. The confidentiality, integrity and availability CIA Triad is one of the core principles of information security. Confidentiality, integrity and availability, also known as the CIA Triad, is sometimes referred to as the AIC Triad, availability, integrity and confidentiality, to avoid confusion with the Central Intelligence Agency, which is also known as CIA. It is considered as the core underpinning of information security. Every security control and vulnerability can be viewed in light of one or more of these key concepts. For a security program to be considered comprehensive and complete, it must adequately address the entire CIA triad. We can go through the basic definitions of confidentiality, integrity and availability. Confidentiality measures are designed to prevent sensitive information from unauthorized access. Integrity is the ongoing maintenance of consistency, accuracy and reliability of data throughout its life cycle. Availability ensures information should be consistently and readily accessible for authorized parties. All of these concepts are important on their own to security professionals of all kinds. The reason these three concepts are grouped into a triad is for the information security professionals can think of the relationship between them, how they overlap and how they oppose one another. Looking at the tension between the three legs of the triad can help security professionals determine their information security priorities and processes. Let us move to the topic CIA Triad. The CIA Triad is widely accepted as a model in information security. This model appears to have developed over time with roots as old as modern computing, pulling concepts from various sources. Ben Miller, Vice President of Dragos, seems to be one of the few people who have done any digging on the origins of the triad. He wrote a blog post about its roots and was unable to find a single source. The three concepts exist in tension with one another when it is worked as a triad. For example, requiring elaborate authentication in turn helps ensure confidentiality, but at the same time, some people who have the right to the data may not get access, thereby reducing availability. First CIA triad is confidentiality. Confidentiality is one of the core concepts of information security. Simply put, confidentiality ensures that secret information is protected from unauthorized disclosure. Only individuals with the legitimate authorization to access the required information should be permitted it, also known as permissions on the need to know basis. At large, the goal of confidentiality is to stop sensitive data from getting into the wrong hands. Confidentiality is the ability not to disclose information to unauthorized persons, programs or processes. It relates to information security because it requires control over access to protected information. Simply stating, confidentiality means that something is secret and should not be passed on to unintentional persons or organizations. If confidentiality is compromised, this can lead to loss of privacy and disclosure of confidential information to the public or other persons. There is a wide range of information that could be considered confidential, such as financial information, medical information, and other sensitive information. Some information is more sensitive than others and requires a higher level of confidentiality. There are a number of measures that can be taken to assist with confidentiality, including multi-factor authentication, strong passwords, encryption, segregation of data, and assigning users with appropriate user privilege levels. However, before implementing such measures, it is important to group your information assets into different classifications according to how much damage could be done if accessed by an unauthorized entity. The higher the negative impact, the stronger the security controls need to be. Threats to confidentiality. Confidentiality can be compromised in several ways. The following are some of the commonly encountered threats to information confidentiality: eavesdropping attacks, encryption cracking, malicious insiders, man-in-the-middle attacks, hackers, unauthorized user activity, unprotected downloaded files, local area networks, and Trojan horses. Confidentiality models. Confidentiality models are used to describe what actions must be taken to ensure the confidentiality of information. These models can specify how security tools are used to achieve the desired level of confidentiality. The most commonly used model for describing the enforcement of confidentiality is the Bell-LaPadula model, or BLP. In this model, the relationship between objects, that is the files, records, programs, and equipment that contain or receive information, and subjects, that is the person, process, or devices that cause the information to flow between the objects. The relationships are described in terms of the subject's assigned level of access or privilege and the object's level of sensitivity. In military terms, these would be described as the security clearance of the subject and the security classification of the object. Another type of model that is commonly used is access control model. It organizes the system into objects, that is resources being acted on, subjects, that is the person or program doing the action, and operations, that is the process of interaction. A set of rules specifies which operation can be performed on an object by which subject. Best practices used to ensure confidentiality. When managing data confidentiality, follow these guidelines. Encrypt sensitive files. Encryption is a process that renders data unreadable to anyone except those who have the appropriate password or key. By encrypting sensitive files by using file passwords, for example, you can protect them from being read or used by those who are not entitled to do either. Manage data access. Controlling confidentiality is in large part about controlling who has access to data. Ensuring that access is only authorized and granted to those who have a need to know goes a long way in limiting unnecessary exposure. Users should also authenticate their access with strong passwords and, where practical, two-factor authentication. Periodically review access list and promptly revoke access when it is no longer necessary. Physically secure devices and paper documents. Controlling access to data includes controlling access of all kinds, both digital and physical. Protect devices and paper documents from misuse or theft by storing them in locked areas. Never leave devices or sensitive documents unattended in public locations. Manage data acquisition. When collecting sensitive data, be conscious of how much data is actually needed and carefully consider privacy and confidentiality in the acquisition process. Avoid acquiring sensitive data unless absolutely necessary. One of the best ways to reduce confidentiality risk is to reduce the amount of sensitive data being collected in the first place. Manage data utilization. Confidentiality risk can be further reduced by using sensitive data only as approved and as necessary. Misusing sensitive data violates the privacy and confidentiality of that data and of the individuals or groups the data represents. Manage devices. Computer management is a broad topic that includes many essential security practices. By protecting devices, you can also protect the data they contain. Follow basic cybersecurity hygiene by using antivirus software, routinely patching software, whitelisting applications, using device passcodes, suspending inactive sessions, enabling firewalls, and using whole disk encryption. Second CIA triad is integrity. Integrity measures protect information from unauthorized alteration. These measures provide assurance in the accuracy and completeness of data. The need to protect information includes both data that is stored on systems and data that is transmitted between systems, such as email. In maintaining integrity, it is not only necessary to control access at the system level, but to further ensure that system users are only able to alter information that they are legitimately authorized to alter. As with confidentiality protection, the protection of data integrity extends beyond intentional breaches. Effective integrity countermeasures must also protect against unintentional alteration, such as user errors or data loss that is a result of a system malfunction. For example, in a data breach that compromises integrity, a hacker may seize data and modify it before sending it on to the intended recipient. Integrity models. Integrity models are used to describe what needs to be done to enforce the information integrity policy. There are three goals of integrity which the models address in various ways. Preventing unauthorized users from making modifications to data or programs. Preventing authorized users from making improper or unauthorized modifications. Maintaining internal and external consistency of data and programs. Integrity models include 5 models that suggest different approaches to achieving integrity. They are the Biba model. The first model to address integrity in computer systems was based on a hierarchical lattice of integrity levels defined by Biba in 1977. The Biba integrity model is similar to the Bell-LaPadula model for confidentiality in that it uses subjects and objects. In addition, it controls object modification in the same way that Bell-LaPadula controls disclosure. Biba's integrity policy consists of 3 parts. The first part specifies that a subject cannot execute objects that have a lower level of integrity than the subject. The second part specifies that a subject cannot modify objects that have a higher level of integrity. The third part specifies that a subject may not request service from subjects that have a higher integrity level. The Gauguin-Messeguer model. The Gauguin-Messeguer model, published in 1982, is based on the mathematical principle governing automatons, that is, a control mechanism designed to automatically follow a predetermined sequence of operations or respond to encoded instructions, and includes domain separation. In this context, a domain is the list of objects that a user can access. User can be grouped according to their defined domains. Separating users into different domains ensure that users cannot interface with each other's activities. All the information about which activities users are allowed to perform is included in a capabilities table. In addition, the system contains information not related to permissions, example user programs, data and messages. The combination of all this information is called the state of the system. The automaton theory used as a basis for this model predefines all of the states and transitions between states, which prevents unauthorized users from making modifications to data or programs. The Sutherland model. The Sutherland model, published in 1986, approaches integrity by focusing on the problem of inference, that is, the use of covert channels to influence the results of a process. This model is based on a state machine and consists of a set of states, a set of possible initial states, and a transformation function that maps states from the initial states to the current state. Although the Sutherland model does not directly invoke a protection mechanism, it contains access restrictions related to subjects and information flow restrictions between objects. Therefore, it prevents unauthorized users from modifying data or programs. The Clark-Wilson model. The Clark-Wilson model, published in 1987 and updated in 1989, involves two primary elements for achieving data integrity: the well-formed transaction and separation of duties. Well-formed transactions, as previously mentioned, prevent users from manipulating data, thus ensuring the internal consistency of data. Separation of duties prevents authorized users from making improper modifications, thus preserving the external consistency of data by ensuring that data in the system reflects the real world data it represents. The Clark-Wilson model differs from the other model, that is subject and object oriented, by producing a third access element, programs, resulting in what is called an access triple, which prevents unauthorized users from modifying data or programs. In addition, this model uses integrity verification and transformation procedures to maintain internal and external consistency of data. The verification procedure confirms that the data conforms to the integrity specifications of the time the verification is performed. The transformation procedures are designed to take the system from one valid state to the next. The Clark-Wilson model is believed to address all three goals of integrity. The Brewer-Nash model. The Brewer-Nash model, published in 1989, uses basic mathematical theory to implement dynamically changing access authorizations. This model can provide integrity in an integrated database. In addition, it can provide confidentiality of information if the integrated database is shared by competing companies. Subjects can access only those objects that do not conflict with standards of fair competition. Implementation involves grouping data sets into discrete classes, each class representing a different conflict of interest. Example: classified information about a company is not made available to a competitor. Assuming that a subject initially accesses a data set in each of the classes, the subject would be prevented from accessing any other data set in the class. This isolation of data sets within a class provides the capability to keep one company's data separate from a competitor in an integrated database, thus preventing authorized users from making improper modifications to data outside the purview. Best practices used to ensure integrity. Some security controls designed to maintain the integrity information include encryption, user access controls, version control, backup and recovery procedures, and error detection software. Generally, three basic principles are used to establish integrity controls. Need to know access. Users should be granted access only onto those files and programs that they need in order to perform their assigned jobs functions. Separation of duties. To ensure that no single employee has control of a transaction from beginning to end, two or more people should be responsible for performing it. Rotation of duties. Job assignment should be changed periodically so that it becomes more difficult for the users to collaborate to exercise complete control of a transaction and subvert it for fraudulent purposes. Third CIA triad is availability. Availability means guaranteeing reliable access to information by authorized personnel. In order to be readily accessible, data must be stored in a logical yet secure system. High availability aids rapid business processing and ultimately benefits your organization. It is every user's responsibility to file desktop documents in a way that makes them easy to locate in the future. Similarly, paper copies should be filed securely and not left lying around. Copies should be made to ensure important information is not irreversibly lost. Certain storage methods are more vulnerable to loss and theft than others. Information on portable storage devices such as USBs is particularly vulnerable. That is why this information should be encrypted and backed up. Temporary displays, example whiteboards and charts, are similarly vulnerable to prying eyes, and information recorded in this way should be transferred to a more permanent, confidential place at the earliest opportunity. Data is often shared not only within your organization but also to individuals outside of your organization, such as customers, business partners, and the general public. Emails are a quick and easy way of sharing data around the world, especially convenient when transferring big data sets. However, information sent over the internet can sometimes be intercepted and accessed by hackers, compromising confidentiality. Encrypting your information can make it harder for hackers to access, as without the decryption key, the data will appear to be nonsense. There are mainly two threats to availability of the system, which are as follows: denial of service and loss of data processing capabilities. The above two facets of availability are explained here. Denial of service. Denial of service specifies to actions that lock up computing services in a way that the authorized users are unable to use the system whenever needed. Availability is also blocked in case if a security office unintentionally locks up an access control of database during the routine maintenance of the system, thus for a period of time. Authorized users are blocked to access. In the computer systems, internet worm overloaded about 10% of the system on the network, causing them to be non-responsive to the need of users in an example of denial of service. Loss of data processing capabilities. The loss of data processing capabilities is generally caused by the natural disasters or human actions is perhaps more common. Contingency planning is the measure to counter such type of losses, which helps in minimizing the time for that a data processing capability remains unavailable. Contingency planning provides an alternative means of processing which involves business resumption planning, alternate site processing, or simply disaster recovery planning, thereby ensures data availability. Security aspects of availability. Generally, three basic issues are aspects of security initiatives that are used to address availability. They are physical issues. The physical issues include access controls that prevent unauthorized persons from coming into contact with the computing resources, various files, and water control mechanisms, hot and cold sites for use in alternative sites processing, and backup storage facilities. Technical issues. Technical issues include the fault tolerance mechanisms, electronic vaulting, automatically backup to a secure location, and access control software to restrict unauthorized users from disrupting services. Fault tolerance mechanisms involves hardware redundancy, disk mirroring, and application checkpoint restart. Administrative issues. The issues come in the administrative aspect of availability are access control policies, operating procedures, contingency planning, and user training. Proper training of operators, programmers, and security personnel can help avoid many computing stages that leads to the loss of availability. Examples of CIA Triad. In the CIA Triad, confidentiality, integrity, and availability are basic goals of information security. However, there are instances when one goal is more important than the others. The following are examples of situations or cases where one goal of a CIA triad is highly important, while the other goals are less important. Consider an ATM that allows users to access bank balances and other information. An ATM incorporates measures to cover the principles of the triad. The two-factor authentication, debit card with the PIN code, provides confidentiality before authorizing access to sensitive data. The ATM and bank software ensure data integrity by maintaining all transfer and withdrawal records made via the ATM in the user's bank accounting. The ATM provides availability as it is for public use and is accessible at all times. Let us see another example. Think of a logging into an e-commerce site to check your orders and make an additional purpose. The e-commerce site uses the three principles of CIA Triad in the following ways. Confidentiality. When you log in, you are asked for a password. If it has been a while since your last login, you may be asked to input a code that has been sent to you or some other form of two-factor authentication. Integrity. Data integrity is provided by making sure your purchases are reflected in your account and allowing you to contact a representative if there is a discrepancy. Availability. You can log into your account whenever you want, and you may even be able to contact customer support at any time of the day or night. Other aspects of security. Non-repudiation. Non-repudiation is the assurance that someone cannot deny the validity of something. Non-repudiation is a legal concept that is widely used in information security and refers to a service which provides proof of the origin of data and the integrity of the data. In other words, non-repudiation makes it very difficult to successfully deny who or where a message came from, as well as the authenticity and integrity of that message. Authentication. Authentication defines those users are who they request to be. Authorization defines the power that it can have over distinguishing authorized users from unauthorized users, and levels of access in between. Authenticity defines the constant checks that it can have to run on the system to make sure sensitive places are protected and working perfectly. Accuracy. The accuracy and completeness of information systems and the data supported within the systems should be an administration concern. Information which has been inappropriately changed or destroyed by external or employees can impact the organization. Each organization should make controls to provide that data entered into and saved in its automated files and databases are complete and accurate and provide the accuracy of disseminated data. Access control. The principle of access control decides who must be able to access what. For example, it must be able to define that user A can view the data in a database but cannot refresh them. User A can be allowed to create updates as well. An access control mechanism can be installed to provide this. Access control is associated to two areas, including role management and rule management. Role management apply on the user side, whereas rule management targets on the resources side. Now let us summarize the important points discussed in this session. Good information security practices protect the data subjects your organizations hold data about and the company's assets. For instance, unauthorized access to personal data could result in identity theft, harm to individuals' rights and emotional damage. Poor information security can result in confidentiality breaches, data loss, data inaccuracies and wasted resources. This can culminate in massive reputational blows along with disciplinary action if those involved acted mindlessly or if proper training was neglected to be offered. Possible disciplinary actions range from internal procedures to hefty fines and legal prosecution. Proper training for all staff members is essential in raising awareness of and properly implementing the information security principles. Hence, the most important aspects of security known as CIA Triad is discussed in detail. Hope this session was useful for you. See you next time. Bye.